Hi everyone, starting weekly contest for 11. Let's get started. Yeah, at the beginning we see that the problem is kind of similar. Uh, Mhm. Font 8 divisible by k. Mhm. Oh, I think it should be some recursion. I think, yeah. Mm. What we can do here? Um, 1 times I over R. If that's not the case, then you just Okay, let's just quickly debug it. Position and manner. Okay. Line 49. Division. Binary power. Let's hope it's working. Oh, cool, it works. It's 8 people already submitted this problem. So what you can do, we can just probably do something like formula minimum, something like that. So we have to count number of Okay, I think I know how to solve it. Okay. Okay. What also you want to do is actually minus pos times r. So should be fine, but if debug it quickly. Okay, so I think issue is over here. Fix. Interesting. So if this is correct, then bug is here. Okay. Y, X, Y, Y, X, Y. Oh God, I'm super slow. Okay, but it seems to be correct. We are not using integers. Everything is long. Let's try to submit it. This might not work, right? Okay. Wrong answer. What's this case? Oh shit. should be fine. Okay, was quite slow. Slept for I slept I guess 3 hours or something. Was playing CS all the night, like Counter Strike. Let's see. What? Maybe not that bad. Maybe not that bad. Yeah. So let's quickly try to solve the problem. Let me explain them. So this problem is basically asking for a number of subarrays where the either number of zeros or ones is at most k, right? Okay, so I mean, always look at the constraint. So the string is up to 50. The length is up to 50, so you can just do brute force, like trying all the substrings, checking that. I mean, if the condition is not met, then break. Otherwise, you just increase the counter. Okay, that's it. The second problem. Yeah, this one is a bit, I would say, less straightforward. So you have like kind of two drinks, and like you have n hours, and for each like hour, you know how much energy you'll gain from either of the drink. I mean, from drink A, from drink B. So basically, you want to get the maximum energy boost. But the thing is that if you switch to another drink, you don't contribute at that hour. I mean, that's going to be like typical DP problem. For example, I mean, I just want to have like a DP, like two-dimensional DP. I want to know the best, like maximum energy I can get at hour I if my last drink was like either A or B. So I want to kind of know the last type of drink I took. So then this is base constraints, like base cases. And let's say if you are and for the next hour you want to drink so by the way 0 is like drink of type A, 1 is like drink of type B. So if you want to drink A, if you want to get a drink A on the next hour, so this what is going to be like I mean, you have two options. Either you just continue like either the last drink you had was drink A, and then you just like use it the next drink basically, or the last drink was B, but now you can't take any drink at the next hour. I mean, in a similar case, yeah. Hopefully it was a bit clear. And then you just get the maximum boost you get at the end. Okay, that's it. So the next problem is even more difficult. So I don't know, maybe there is a easier solution comparing to mine, but what I did, so since the constraints are big, the length is up to 10 to the 5th, obviously it should be some maybe math problem or some like recursion DP problem. So I didn't come up with any like straightforward solution that is some logic or like some math logic. Yeah, but what I did, I just did some like recursion with memorization. So what I'm doing here, I'm trying to build a string itself here. So for example, we know that let's say if n is like 5, okay, so you have like 5 spots, like we have 5 digits, okay. So let's say if I put a digit, I don't know, 4 here, I obviously have to put digit 4 at the end as well. So okay, easy, right? But the thing is that we also have to maintain like a remainder of division by k, so that's not hard. So in this case, we have to update our like remainder to, so let's say if our remainder was like r, so it will be like r plus 4, right? Because we are adding 4. I mean, not like remainder, but result of remainder of division by k plus 4 times how much? Like this is like 1, 10,000, 100,000. This, so this is going to be like 400,000, right? So this, I mean, if you're putting here 4, it means that we have 400,000 like as this basically like part or base modulo k. Yeah. So this is how we are actually updating our remainder if you're actually just putting digit by digit. So nothing difficult. So what I do, I'm just trying to start from the biggest digit, go to the smallest digit, and then I somehow update my remainder, and then I say if by putting this digit actually can build a string, that's going to be the answer. Like I want to use that digit. And the case when I know that I can build the digit, build the number that is like that satisfy all the conditions, is basically that at the end remainder is 0 of division by k. Yeah, that's it. Just like recursion, I add memorization, so it's fine. So it will be working. Time complexity here is like n times 10 squared or something, and some maybe extra complexity for doing binary power. Yeah, I didn't want to calculate time complexity because I knew it should pass. Okay. What else? So next problem is this one. Yeah, I mean I like actually such type of problems. You have to find like number of subarrays for each query. Basically, this is the first problem, but here you have like queries, and obviously the constraints are big, so you have to find some efficient solution. So, I mean, obviously, if you will be doing like, if you will be searching or calculating number of subarrays for each query like independently, without any pre-calculation, it will be quite slow. It's going to be like number of queries times n, where n is the length of the string. So what I came up with. So imagine this was our query, like to find answer from L to R. And let's suppose we have such array next, which means where I store the rightmost position to I, where this subarray actually met the condition that, I mean, there is at least 0 or 1 where the accuracy is at most k. For example, if we consider this subarray, then there is, I mean, then this is not like good. Condition is not met here. Okay. I mean, if you know such, if you have such pre-calculated array, then the answer is going to be this, right? Because from I, you can, let's say if I is the beginning of your subarray, the ending position can be anything from I to next of I. But sometimes next of I could be even bigger than R, that's why I limit it with minimum. Yeah, that's going to be the formula to calculate the answer. So, but still, you see, I mean, if you'll be calculating your answer by doing like this, it's still slow. It could be up to, I mean, it could be all of n in the worst case, so it's going to be like n squared or like or n times q in the worst case. So we have to calculate this formula quite, I mean, more efficient, in a more efficient way. So for this, you have to notice that next of I is always like less than or equal to next of I plus 1. So it's like always increasing, right? That's the main observation. So this means if you have like if this is your subarray of array next from L to R, I mean, obviously there is some position at which next of that position becomes greater than R, right? So let's say we have this position X. So that's gonna mean that our formula here will now look like that from L to from L to X, we just do something like this, I believe, and from X we'll be updating our answer by doing something like R minus I plus 1. You see, because starting from that position, next of I is actually exceeds R, right? So, I mean, we can actually optimize these parts so that we don't have to for loop. So here, I mean, imagine we don't have this like I minus I plus 1, okay, for now. I mean, obviously we can just, this is always like a constant which we can add at the end. This is going to be like, I mean, just imagine we have some additional that later. So now what actually, the way to calculate it like efficient, well, it's just like sum of elements on a certain like range, which we can actually do with prefix sums. We can do something like pref of x minus 1 minus something like that for this part. Yeah. And for this part, you see we always adding like a constant. So this is going to be just like R times R minus 6, that's it. So that's the way we optimize our solution to like log of n, not like of n for responding to query. And for this part, I mean, just try to come up with your own solution, but just some formula, like math formula. So here you can see my code. This is the way I find the position, like where next of that position exceeds R. Yeah, that's it. Hopefully it was helpful. If you have any questions, just leave them in the comments below. Yeah, thank you for your time. So I'm, I think, 28 or something. Yeah, I think I'm 28. I mean, not that bad. I assume that I was super slow. Like I was doing 20 minutes for this problem, really. Yeah, okay, it's fine. Any friends? I don't see anyone. Okay. Yes, thank you so much again, and bye-bye. Wish all the improvements in your competitive programming endeavors.